Great. I want to continue with our examples on the roots and coefficients of the quadratic equation. So let's look at this question. If alpha and beta are the roots of x squared minus kx plus p equals 0, find the values of a, b, c, and d. Good. So these are the 4 questions that we are going to try to find answers to. So first, let's pick the quadratic equation. Is x squared minus kx plus p equals 0. I want to find our sum of roots, that is alpha plus beta, and that will be the negation of this. So you get negative k, that is k. So the sum of roots is k. Then the product of roots is p. Remember that always the value here will be unity. If there's any other number apart from 1, then you divide through so that the value here will be unity, right? So we have our sum of roots and then our product of roots. Now, so A, we want to find this. So we find our LCM as alpha beta, beta into this give us alpha, so alpha times alpha gives us alpha squared. And alpha into this will give us beta, so beta times beta is beta squared. Now, from here, we can express this in terms of the sum of roots and the product of roots. So we can express this as alpha plus beta all squared minus 2 alpha beta from this. This one, when we want to expand, we shall get alpha squared plus 2 alpha beta plus beta squared. So when we try to maintain this 2 on one side, then we shall get this as alpha plus beta all squared minus 2 alpha beta. Now with this established, we can now do the substitution. So the sum of roots is k, so k squared, and then the product of roots times 2 will be 2p over p. So that does it for question A. Now, from there, we want to move on to B. So we have the whole of this expression. Now, for us to be able to do that, then we need to look at the LCM. So the LCM will be alpha squared and beta squared. So beta squared into this will give us alpha squared. Alpha squared times alpha squared gives us alpha raised to the power of 4. And then alpha squared into this will give us beta squared. So beta times beta gives us beta raised to the power of 4. Now from there, we want to get a value for this one, expression for that. So let's start from here. So now alpha plus beta raised to the power of 4 will give us alpha raised to the power of 4, 4 alpha cubed beta plus 6 alpha squared beta squared plus 4 alpha beta cubed plus beta raised to the power of 4. And this is by way of using the Pascal's triangle, where we start with alpha raised to the power of 4, reduce the power by 1, we introduce our beta, reduce the power from here by 1, introduce another power. Then we reduce this by 1, and then increase our beta to beta cubed. And then we now reduce this by 1, giving us 0, so alpha is the power 0 is 1, then we increase this by 1, so you get beta is the power 4. Then the coefficient for the power 4 will be 1, 4, 6, 4, 1. With this established, let us try to simplify what we have in the middle. So we will pick 4 alpha cubed beta plus 4 alpha beta cubed. And when we do that, with some factorization, we shall get this. Now, when we get this, we need to express this in terms of alpha plus beta and alpha beta. So from a previously solved question, we can get the alpha squared plus beta squared being equal to this. With this, we can now multiply through, so 4 alpha beta times this will now take us to the next level, and then 4 alpha beta times negative 2 alpha beta will give us 8 alpha squared beta squared. Remember that we have 6 alpha squared beta squared, so we shall get negative 2 alpha squared beta squared. Now we need to rearrange and leave this on one side, and then we leave the beta with the power 4 on one side. When we do that, then alpha with the power 4 plus beta with the power 4 will give us this on the right-hand side. Alpha plus beta with the power 4 minus 4 alpha beta, alpha plus beta all squared plus 2 alpha squared beta squared. Now, with this established, we now move on to the original expression where we got this. So in place of alpha raised to the power 4 plus beta raised to the power 4, we shall represent that by this expression. So in place of alpha plus beta, we put our k, alpha beta put p, alpha plus beta put our k, and then our p. Then the denominator alpha squared beta squared will be p squared. And so that is what we have on this side. So we've been able to find the value of that. Fantastic. Now I want to move on to C. Then we have this in the bracket. Let us try to find a common LCM for them. So pick B. So LCM is B. So alpha over 1 into beta will give us beta. So beta times this will be alpha beta plus 2. And then we come here. Our LCM will be alpha. So beta on 1. And then 1 into alpha gives us alpha. So times this is alpha beta plus 2. So we have alpha beta and the denominator or the LCM. Now, because the two numerators are the same, we have alpha beta plus 2 all squared. Okay, so with this established, we can now say that our alpha beta is p, so p plus 2 all squared, and then over p. So we can expand. We have p squared plus 4p plus 4 all on p. Now, we now want to move on to D. So 1 on 3 alpha plus beta plus 1 on alpha plus 3 beta. So pick this and that as our LCM. Now 3 alpha plus beta into that will give us this. So we have alpha plus 3 beta. Now alpha plus 3 beta into this will give us 3 alpha beta. So that times 1 gives us this. Now let us now try and group all the like terms. So alpha plus 3 alpha will give us 4 alpha. 3 beta plus beta will give us 4 beta. We can now do some factorizations. Now the denominator, we multiply them out. 3 alpha times alpha gives us 3 alpha squared. 3 alpha times 3 beta gives us 9 alpha beta. And then beta times alpha gives us alpha beta. And then beta times 3 beta gives us 3 beta squared. Now with this, we can do the factorization in the numerator. So we get 4 into alpha plus beta. Then over here, 3 alpha squared, 3 beta squared comes here. Then 9 alpha beta plus alpha beta gives us 10 alpha beta. So over here, we can try to expand this one and write it in terms of sum of roots and the product of roots. And from the previously answered question, alpha squared plus beta squared will be written this way times R3. Okay, from there, so we see that this alpha plus beta will give us k, so k squared. Then 3 times 2 give us 6p plus our 10 alpha beta. So that will give us 4p. So negative 6p plus 10p give us 4p. So finally we get to this point. 4k on 3k squared minus 4p. That is fantastic. So let us go through it. Take your time. You can go back and look at the solution, all that we have done. The question was given us by the following. If alpha and beta are the roots of x squared minus kx plus p equals 0, then we find the following values. Question A, question B, question C, and question D. And I took you through how we can find the sum of roots, the product of roots. Then we moved on into solving A. We went through that. That took us here. Then we went through the B. Then went through the C. I went through the D. Look at the D. Great. Thank you so very much for your time. Continue to do lots of practices for you to be grounded in this. Thank you so very much.